In this video, let us continue to solve trigonometric identities. Here we have to prove two of the trigonometric identities, which is secant square x plus cosecant square x is always greater than or equal to 4. And the second one is if 10 times sine to the power of 4 alpha plus 15 cos to the power of 4 alpha is equal to 6, then we have to prove the second equation, which is 27 cosecant to the power of 6 alpha plus 8 secant to the power of 6 alpha. What is the value of this? So that is what we have to find. So let's get started. So let's address the first problem. Here we have to prove that secant square x plus cosecant square x will always have a value greater than or equal to 4. Now let's apply the trigonometric identities. Secant square x can be written as 1 plus tan square x, and cosecant square x can be written as 1 plus cot square x. So this will be 2 plus tan square x plus cot square x. Now tan square x plus cot square x, we have reached a dead point. So now we go back to our previous implementations in the previous videos. So what we do is, here we can add and subtract 2 times tan x cot x plus 2 times tan x cot x. So this does not, addition and subtraction does not change the entire value because these two will cancel out. But it gives us a chance to apply the algebraic equation, which is a minus b the whole square, which is a square plus b square minus 2ab. So let's apply this. So we will have 2 plus tan x minus cot x the whole square plus 2 tan x cot x. So this will be a cancelled situation here because tan x into cot x is 1 because they cancel out each other. So we will have 4 plus tan x minus cot x the whole square. Now if you notice here, what are the possible values of this part of the equation? It is either 0, where tan x minus cot x will result in a value 0, or even if it is a negative value, there is a square here. So this will be 4 plus some positive value. Correct? Or 0. So this is how we can prove that the resultant value will always be either equal to 4 or greater than 4. So this is nothing but we can represent it as greater than or equal to 4. So this is how we can prove the first question in this video. So let's solve the second problem now. Here we have been given the information that 10 times sine to the power of 4 alpha plus 15 times cos to the power of 4 alpha is equal to 6. We have to find the value of 27 cosecant to the power of 6 alpha plus 8 secant to the power of 6 alpha. So let's see how we can use this information. So 10 times sine to the power of 4 alpha plus 15 cos to the power of 4 alpha is equal to 6. So there is nothing much we can do here other than adding or altering this equation somehow so that we arrive at any one of the values of a trigonometric function. So cosecant square alpha is 1 plus cot square alpha, and secant square alpha is equal to 1 plus tan square alpha. So somehow if we find the value of tan alpha, then we can substitute cosecant with the trigonometric identities and then find the value of this 27 times cosecant to the power of 6 alpha plus 8 secant to the power of 6 alpha. So we have to find the value of tan square alpha using this data. So now what we can do is, let us multiply this with sine square alpha plus cos square alpha the whole square. So the value of this equation did not change because sine square alpha plus cos square alpha is 1. We are just multiplying it. Now why did we square it? So that we get a chance to cancel out or solve the sine to the power of 4 alpha here. So now what we can do is divide both the sides by, now let's solve this equation first. So this is easy. Sine to the power of 4 alpha plus 15 cos to the power of 4 alpha is equal to 6 times sine to the power of 4 alpha plus cos to the power of 4 alpha plus 2 sine square alpha cos square alpha. Correct. Now let's divide both the sides by cos to the power of 4 alpha. So this will be 10 times tan to the power of 4 alpha plus 15 is equal to 6 times tan to the power of 4 alpha plus 1 plus 2 tan square alpha. Correct? We are dividing both the sides of the equation by cos to the power of 4 alpha. So this is nothing but 1 plus tan square alpha the whole square times 6. Correct? And the left hand side will be 10 times tan square alpha plus 15. So this is what we have now. Now let's solve this equation. What would we get? So I'm just explaining it here. So let's ignore this part for now. So this will be 6 times tan to the power of 4 alpha plus 6 plus 12 tan square alpha. Now let's solve this. This will be this is tan to the power of 4 alpha. 4 tan to the power of 4 alpha plus 9 minus 12 tan square alpha is equal to 0. So now let's see what this is. If we consider this as A and this as B, this will be 2 tan square alpha minus 3 the whole square is equal to 0. So we would have tan square alpha is equal to 3 by 2. So now we found the value of tan square alpha. Now we have to apply that value in 27 cosecant to the power of 6 alpha plus 8 times secant to the power of 6 alpha. Let's solve that now. So let's solve for the value of 27 cosecant to the power of 6 alpha plus 8 secant to the power of 6 alpha. So we are replacing cosecant to the power of 6 alpha with 27 cosecant square alpha cube plus, we are changing secant to the power of 6 alpha with 8 times secant square alpha whole cube. So now we are applying the trigonometric identity here. So this will be 27 times 1 plus cot square alpha the whole cube plus 8 times 1 plus tan square alpha the whole cube. Now we know the value of tan square alpha. We found that out to be 3 by 2. So if tan square alpha is 3 by 2, cot square alpha would be 2 by 3. It's just the inverse. So this will be 27 times 1 plus 2 by 3 the whole cube plus 8 times 1 plus 3 by 2 the whole cube. Now let's solve this. We would get 27 times 125 divided by 27 plus 8 times 125 by 8. So if we solve this, we would get 125 plus 125 and the value is 250. So this is how we can solve the equation by applying trigonometric identities. If you like the video, please share it with your friends so that it's helpful to them also. Thank you for watching.